Let me introduce myself. My name is Yulina Putriani, and today I would like to present my research with title of Physical Processes Parameterization effort by comparing 3D numerical model to track marine plastic debris or track MPD and GPS drifter released in various locations. I will start with introduction, methodology, result, and at last conclusion. Near surface tracking knowledge is important for many problems such as debris tracking in near surface ocean, whether it is debris from daily human activities such as litter or debris from plane or ship accident. In the case of plane or ship accident, near-surface tracking is also important for the rescue mission. Near-surface tracking is only possible if ocean products are available and accessible. In the past few years, more ocean products become more accessible, such as ocean current from satellite and numerical model, and also other forcing like wind on surface. 3D numerical modeling helps the tracking processes to become more accurate by predicting trajectories from various physical processes that happen in near surface. One of available 3D numerical model for near surface tracking is track marine plastic debris or track MPD. Track MPD is a 3D non-Lagrangian particle tracking model that includes not only advection and diffusion, but also other physical parameters like windage, pitching, washing off, sinking, deposition, and the other physical parameter. Compared to Eulerian view, Lagrangian view provide the particle history from the origin up to its location after a certain period that make it more appropriate for tracking purpose. Other than tracking purpose, Lagrangian view also widely used for ocean circulation, also interbasin relationship. Other than ocean current itself, other forcing like surface wind and physical processes like diffusion, coefficient play important role in altering the trajectory of particle in ocean. To understand how these two affect the trajectory of particle, we compare results from track MPD to drifter released in several locations in different periods. There are several pairs of drifter that have been released from between 2018 to 2022. The first one is in Bering Sea 2019 and 2020, and next is in east of Japan 2018 and 2019, south of Jeju 2022, and last one is West Pacific 2020. In each location there are around 20 to 30 drifter release, and each drifter were released in pairs. For this experiment, we used ocean current data that obtained from Copernicus marine surface with spatial resolution 0.22 and temporal resolution is daily. Wind data used was 10 meters from surface, and the data was obtained from NOAA website with spatial resolution of 2.5 degree. For the analysis, wind data was interpolated to 0.25 degree resolution to match the ocean current resolution. Track MPD also include interpolation sim for both spatial and temporal resolution, and in this experiment the daily data input were interpolated to hourly data so that the output will be hourly. And for advection, Rangé-Kuta sim determined were used, and this sim determine value at t plus 1 by using value at t plus weight average of 4 increment. And for the turbulence processes, they use the random walk model for the horizontal direction. Random walk model is used to simulate turbulent particle motion in a random fluctuation of a particle in certain subdomains, followed by another relocation to another subdomain. And for this simulation, configuration used is for plastic with density less than 1 gram per centimeter cube, with no biofouling and no degradation. Fraction of wind and diffusion coefficient were used as variable for parameterization effort. And for each region location, we release 1,000 particles at the same point of the drifter pairs. The first location is Bering Sea. We release several drifters from two different periods, 2019 and 2020, and we compare the trajectory of the drifter with the track MPD result. From both two different periods, the drifter trajectory show more similarity with the track MPD result when no wind force included. So the pink one is the trajectories produced with no wind force included, while adding only 2% of the wind velocity into the calculation, causing the trajectory into more different direction. And from this we can rule out wind roll in this region. But even with the result from simulation with no wind, there's only some track that follows the direction of the drifter, while the other trajectories, the area that is covered by the trajectories is much more larger than the drifter, especially in 2019. And seeing this result, we try to compare different diffusion coefficient in this region. And here is the result with the different coefficient, diffusion coefficient of 3 and also 12. From both period, we can see that different diffusion coefficient doesn't show contrast different. Both coefficients still result in similar area of the trajectories, with the previous one 10 meters square per second, so that we can conclude that there are no other forcing in this region that dominate, that there are other forcing in this region that dominate the physical processes. And so further research is needed to understand more processes in this region. Other region that show no wind roll is in east of Japan, 2019. In this region, we can see that the drifter trajectory show high similarity with the track MPD trajectories produced with no wind force, while the trajectory produced with the 2% of the wind force show that it's directed into different direction with the drifters. But on the same region of East Japan 2080, we can see that the result of the track MPD is showing similarity for both with wind force simulation and also no wind force simulation. So like for at this one, we can see that it follows more the trajectory of the no wind simulation, but this trajectory follows more the simulation with 2% of the wind force. And same result also observed in other region, West Pacific 2020 and also south of Jeju 2022. From some initial release point, the trajectory followed the trajectory of the drifter followed the track MPD trajectories forced with wind, like this one, the green one, but other follows the simulation result with no wind force included. This and at the south of Jeju also the same case. So from some of the initial release point, the trajectory followed the simulation result with the wind force, but from other release point it follows more the simulation with no wind force. And to conclude this presentation, we can see that the physical processes covered in this discussion, so its wind and diffusion coefficient, have unique role for each region and also for a unique time period. And even though for some region like Bering Sea, the result of track MPD show larger coverage of trajectories rather than the released drifter, track MPD display good accordance with other released drifter in other location and period, especially in West Pacific 2020, East of Japan 2018 and 2019, also south of Jeju 2022. With some of the drifter trajectory show more similarity with no wind simulation, and other show more similarity with wind force calculated in the simulation. This result does show that the effort to parameterize physical processes need more research to find more on how the variable varies with time and space. Thank you for your time.